Okay, so let's start. Good afternoon, and I'm going to talk about what we do at Mellanox, and then give you some examples. I don't know if you know, but about a few days ago, there was an announcement that one of our ex-ministers was accused of espionage, of spying for Iran or something like this. I think one of the interesting questions is not why didn't we not catch him earlier, but another question is how many more spies are here and how can we catch them? And I think this information is, or those questions are things that can be answered by machines, and I'll give you some of the infrastructure that can build those things and some things that I think other countries are doing, and lead through this presentation the infrastructure needed to build such machines. So the first thing, we're now in a data-centric world. If you looked centuries away, real estate was the main source of wealth, then it was energy, now it's data. So we're in a data-centric world, and what you need to find out is how you can utilize this data for your benefit. Every day, there are more appliances and more applications generating and consuming data, and this is just growing on a daily basis. We're seeing some of the markets and applications that use and generate data. This is just one example. You know, cars. They generated huge amounts of data. Think of airplanes. Mellanox now has our technology designed into some of the cars that are now wiring more than 100 gigabit per second technology in cars in order to move data efficiently in the car, store, compute, and do some more things inside the cars. So the amount of data generated and can be processed and utilized is growing very, very fast. Those are just some applications where we can help grow faster. So I'll give you a short break and tell you what we do. What we do is we move data the fastest in the planet. So we move data from storage to servers, and then from servers to servers, today at 100 gigabit per second, very soon at 200 and 400 gigabit per second this year, which basically means it enables you to analyze, compute, store, retrieve, manipulate data at a much faster speeds than with any other interconnect. And you'll see in one of the slides, we're part of the smartest supercomputer in the world today. But those are some examples of fraud detection. You have 300 milliseconds to decide if it's a fraud or not. If in those 300 milliseconds, you can only look at 10,000 data registers, you can make a decision. But if you can look at 1 million data insertions, the decision of fraud or not fraud will be much more accurate, and the price of fraud detection, or actually not recognizing fraud, will be much smaller. We're talking about cloud, you know, energy, looking for oil, for gas, genomics, security, safer. Everything can do better with more data and faster data moving between different elements in the data center. So what we do is we help analyze. If you have a lot of data, we help you analyze what's going on, make the right decisions with more accuracy and better success. Just one example in terms of electronic payments, we've helped JD.com and Alibaba, through a lot of things, analyze and do $26 billion and $16 billion of movements in one day with very small fraud throughout those single days in China or around the world. Those are some of the things we're doing in a lot of applications. What you see here is a simple example. The more data the computer can look at a certain period of time, the smarter it becomes. So if you can move more data into the compute engines, the computer you have is smarter. We're doing this in many places, in Baidu, in Facebook, in Microsoft, in many other places, where we help them analyze and do more stuff. Our Interconnect is designed to work with any CPU architecture. So we can have support for GPUs from NVIDIA, and working very closely with NVIDIA on the architecture of the systems. It can be ARM. There was just announced of the largest ARM supercomputer just this week. We can obviously work with FPGAs, Intel, and any storage elements such as flash DRAM, and other things. Those are the building blocks that we provide. So sometimes you're not even aware of how you get those results. And then your AI infrastructure will get very low performance, or you will be limited. And this is sometimes people don't realize why they have limitation in what they can do with the data they have. Imagine that you're trying to do things, but you're blocked with the time it takes you, or the amount of data you can analyze, or conclusions, or algorithms you can run, and so on. Now, if you have much wider data path or connectivity between the different elements in the data center, you can run much faster, and you can do many more things that before was either impossible or very hard to do. And that's exactly what we find ourselves doing with those building blocks inside the data centers. Not only that, we also offload a lot of the functions from the main CPU to our devices, so we let the CPU and the GPU do much more work for the application rather than manage the interconnect. On top of that, we've learned and we've worked with NVIDIA, with IBM, and with others. If in the past, most of the computation was done at the endpoints by the CPUs or GPUs, and the network was just simple pipes, just transferring data, now we're moving and we're enabling the network to do part of the computing. So we do in-network computing, and that helps to synchronize if there's an algorithm that have barriers, that have multiple synchronization elements. We do those things inside the network rather than at the endpoints, and thus enabling to run 10x in terms of time spent in multiple functions between the different elements. Those are some examples of offload engines and algorithms that today may seem to you not so relevant for AI. But if you look at the numbers, for example, the sharp inside our switch, where we do AI offload in floating point engines inside the switch, we get 10x performance improvements with some of the algorithms. With GPU Direct, I just heard, I cannot repeat the name, but a large Web 2 company that all of them, most of you guys use, wanted to build an AI machine. And they used GPUs, initially without Mellanox. And they saw a lot of bottlenecks in the data getting to the GPUs. They put Mellanox inside, they got 100x performance factor, 100x. All of their architectures changed to utilize Mellanox. So you're sometimes at a very high level writing the software, the applications, but it's pretty good that you understand what's running down here so that your algorithms can do much more efficient, you can get better results, and so on. This is just a sample of the people we work with. There are many more. Obviously, we also have a lot of agencies in the US, in China, that cannot be on this foil, but we help a lot of people do a lot of stuff with AI, with huge amounts of data. Just as a simple example, Summit was announced, I think, 2 weeks ago in the US by Cornell Oak Ridge National Lab. It's the largest supercomputer in the world, but what's more, it's the largest AI machine on the planet. So it's the smartest computer. It has about 27,000 GPUs in one systems connected. So imagine what can be done with this supercomputer. Before that, the largest supercomputer in the world was in China, also connected by Mellanox. So we're giving people very fast computers, and now we're in the race for exaflop machines that will come out there. We have very good collaboration with NVIDIA. We're inside their appliances. Both the DGX1 and GGX2 have multiple Mellanox interconnects using mainly InfiniBand, but also now Ethernet. Those are some of the people that use us today. And you know, there's a company here called SenseTime, a Chinese company by a professor or a bunch of professors from Hong Kong. They've beaten Google in image recognition, I think, multiple years because of the infrastructure they're using. So it's not just the algorithm, but the infrastructure they used helped them beat multiple very large companies in image recognition because they can move data faster and do more stuff. Our interconnect is full end-to-end, so if you choose to use Mellanox, by the way, you don't need to buy this gear. If you go to Azure, Azure Cloud by Microsoft has multiple HPC, and soon you'll have more clouds offering this, but you have this available at your fingertips if you decide, and then your AI algorithms can run much faster. So I'm done earlier. I'm giving you back some time. Thank you very much. Have a good day.
Very good surprise. I like such surprises.